In this problem, it says quadrilateral ABCD is a parallelogram. Q is the midpoint of AB, R is the midpoint of QB, S and T trisect DC. We want to determine the ratio of the area of quadrilateral AESD to the area of RET. Okay. Now, because this is a parallelogram, we know several things. We know that AB and CD are not only parallel, but congruent. So I'm going to call this B and B for our base. Okay, so that means we have A right here, we have B, we have Q, and we have R. So this AQ is 1/2 B, QR is 1/4 B, and RB is 1/4 B. Down at the bottom, we have D here, we have C, we have S, and we have T. Now this is trisected, so that means each of these are 1/3 the base. Okay, so we have R right there with S, and we have point E. Okay, so what we want is we want this region, the area of this region, divided by the area of this region. But they don't give us any measurements besides this. Now, I'm just going to call the height of this thing H, whatever it is. And the one thing I notice is that if I look at it, this triangle SET is sort of held in common with this. Here's what I mean. Here's what we're asked to find: AESD divided by the area of RET. Well, what we can do is we can say, wait a minute, AESD is really just triangle ADT with triangle SET taken out. And the same thing can be said for RET. RET, this triangle, is really RST with triangle SET taken out. So what we have is we just have the area of these triangles to figure out. Well, we know for ADT, the base is 2/3 B and the height is H. For RST, the base is 1/3 B and the height is H. That's good. But SET is where we run into some problems. So we're going to take a sidestep and look at this one. Now here's the thing to note. The fact that it's a parallelogram is key to this problem, because we know that this angle and this angle are congruent. They're alternate interior angles. So are these right here. And because these are vertical angles, these are congruent. So triangle SET and REA are similar. Okay, so how does that help? Well, notice that because they're similar, look at their bases. We can make a comparison of their bases. And because of that, we can also make a similar comparison of their heights. So off to the side here, I'm going to draw SET. And the base of SET is 1/3 B. And for the other triangle, REA, the base is 3/4 B. So whatever the heights are, I'll just call this H1, and I'll call this H2. We know that they're in this proportion. They're in the ratio of 1/3 to 3/4. I just canceled out the B. All right, now we're dividing fractions. That's the same as multiplying by the reciprocal. So the heights are in the ratio of 4 to 9. H1 over H2. So that means that the total is something of a multiple of 13. So that means that this right here, this height, is 4/13 of whatever H is. And that's our key to answering this problem. Because knowing this, now we can find the area of SET, and so now we can find this ratio. So ADT, 1/2 the base. So ADT right here, the base is 2/3. Times the height. It's the height of the entire parallelogram, so that's H. Minus triangle SET. So that's 1/2. The base is 1/3 B. Times the height, which is 4/13 H. All over RST. So that's this triangle. RST, the base is 1/3 B. And the height is H minus. And then we have SET again. Now to save some time and to make things a little simpler, every term here has a B and has an H. So we can cancel that out of everything. So I'll do that. So I'm left with 1/2 times 2/3 minus 1/2 times 1/3 times 4/13 all over 1/2 times 1/3 minus 1/2 times 1/3 times 4/13. Okay. So 1/2 times 2/3 is 1/3 minus 1/2 times 1/3 times 4/13. So a 2 can cancel here. So we're going to be left with 2 over 39. Here we're going to have 1/6 minus 2 over 39. Okay. So to make this easier on us, we're just going to multiply our fractions away. So we're going to multiply the top and the bottom by 39 to get rid of those fractions, and 6, because 6 will get rid of both this and this. So that whole quantity on top is multiplied by 39 and 6. So 39 times 6 divided by 3, 78. 39 times 6 times 2 divided by 39 is 12. And then on the bottom, 1/6 times 39 times 6 is just 39. And then that's going to be 12. So 78 minus 12 is 66. 39 minus 12 is 27. So we can take a 3 out of the top and out of the bottom. So we're left with 22 over 9. And there's our ratio. And we're done.